Hello class, today we're going to go over 6.6 notes, solve radical equations. We'll start by looking at this box of general information first on how to solve a radical equation. For the first step, you want to isolate the root on one side of the equation. If it's already isolated, you can skip that step and you can go to step 2, which is raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or polynomial equation. So essentially step 2 just means we're getting rid of that root by raising each side to a power. And step 3 is to solve the polynomial equation using techniques you've learned in previous chapters and then check your solution. So let's go ahead and practice using these steps in example 1. For example 1, we have solved the square root of 5x minus 9 equals 11 and then check the answer. So I'm going to start by writing the square root of 5x minus 9 equals 11. So I'm writing down my original problem. The opposite of square root is squared, so I am going to square both sides. This gives me 5x minus 9 equals 121. I'm going to add 9 to both sides. 5x equals 130. And then I'm going to divide by 5. So x is going to equal 26. Now we can check that answer by plugging it into the original problem. So I'm going to do the square root of 5 times 26 minus 9 and see if that equals 11. 5 times 26 is 130. Minus 9 equals 11. So I get the square root of 121 equals 11. And it does check out. So that's it for problem number 1. Now for problem number 2, we have 2 times the cube root of x minus 3 equals 4. We're going to solve that and then check our answer again. I'll go ahead and write down that original problem. 2 times the cube root of x minus 3 equals 4. I need to get rid of the 2 first, so I'm going to divide both sides by 2. This gives me the cube root of x minus 3 equals 2. The opposite of cubed root is cubed, so I'm going to cube both sides of my equation. This gives me x minus 3 equals 8. Then I'm going to add 3 to each side to get x equal to 11. To check my answer, I'll plug it into the original problem. 2 times the cube root of 11 minus 3, and we're going to see if that equals 4. 2 times the cube root of 11 minus 3 is 8, equals 4. 2 times cubed root of 8 is 2, so I have 2 times 2, and that is in fact 4. So that's it for example 2. Now we're going to move on and look at rational exponents. When an equation contains a power with a rational exponent, you can solve the equation using a procedure similar to the one for solving radical equations, except for in this instance, after you isolate the power, you're going to raise each side to the reciprocal of that exponent. Okay, so we're just going to raise each side to the reciprocal to get rid of whatever exponent we have. Let's go ahead and look at example 3 for this. We have in parentheses x minus 4 to the 2/3 power minus 9 equals 16. So we do first have to get the quantity that is raised to a power alone, which means that we need to move that 9. So in order to move the 9, I'm going to add it to each side. So we get x minus 4 to the 2/3 power equals 25. Now at this point is where we need to get rid of that power. So to get rid of it, we're going to raise both sides to the reciprocal. Looking at this problem, the reciprocal of 2/3 is going to be 3/2. So I'm raising both sides to the 3/2. Okay, so what this means is that we're raising each side to 3/2 means that we're square rooting and then cubing. Okay? Since we are square rooting, there's going to be 2 possible answers. So I am going to have the absolute value of x minus 4 equals the square root of 25 cubed. That's the same as to the 3/2. So the absolute value of x minus 4 equals 5 cubed. absolute value of x minus 4 equals 125. So now we will split it up. X minus 4 equals 125. X minus 4 equals negative 125. And then we solve each. So x equals 129. X equals negative 121. So whenever you are raising to a rational exponent that has a denominator that's even, you are going to have two possible answers there. Now we need to check both of them. So for the first one, I'm going to check 129. So I have 129 minus 4 to the 2/3 minus 9 equals 16. So 125 to the 2/3 minus 9 equals 16. So this means we're taking the cubed root of 125 and then squaring it, minus 9. So the cube root of 125 is 5. So we have 5 squared minus 9 equals 16. Well, 5 squared is 25. And we get 16 equals 16. So we know that 129 works. Now let's check the next one. Negative 121 minus 4 to the 2/3 power minus 9 equals 16. So it's negative 125 to the 2/3 power minus 9 equals 16. So that's the cubed root of 125 squared. 5 squared minus 9 equals 16. So we end up getting the same thing. 25 minus 9 equals 16. 16 equals 16. So we're good. And that's it for that problem. Now for the next one, example 4, we're going to solve the square root of x minus 6 equals x minus 8 and then check our answer. So I'm going to go ahead and rewrite this problem. Square root of x minus 6 equals x minus 8. So I want to get rid of that square root. I'm going to square both sides. This gives me x minus 6 equals, now x minus 8 squared is x minus 8 times x minus 8. So I have x minus 6 equals x squared minus 16x plus 64. Now I'm going to get everything to one side. So I'm going to subtract the x and add the 6. 0 equals x squared minus 17x plus 70. And now I need to solve this quadratic. I'm going to factor it, and that should be the easiest way. So I'm going to do x minus 7 times x minus 10. X minus 7 equals 0. X minus 10 equals 0. So I get x equals 7 and x equals 10. So those are the two answers I get, but I need to make sure that they both work. So I'm going to check them by plugging them back into the original problem. So when I do that, the square root of 7 minus 6 equals 7 minus 8. So I get the square root of 1 equals negative 1, which leaves me with 1 equals negative 1. That is not true. That means that 7 is an extraneous solution, so we are going to cross that out. It doesn't work. Let's go ahead and check 10 to see if it works. Square root of 10 minus 6. We're going to see if that's equal to 10 minus 8. Well, 10 minus 6 is 4, so I get the square root of 4 equals 2. Square root of 4 is in fact 2. So our only answer that works is x equals 10. All right, for our last problem here, we're solving the square root of x plus 2 plus 1 is equal to the square root of 3 minus x, and we're going to check our answer. So let me go ahead and write this problem down first. Okay, so for this problem, we have square roots on both sides. We need to be able to get rid of at least one of the square roots. So let's go ahead and square both sides to get rid of the one that's over the 3 minus x. So I'm going to square the entire quantity on the left and on the right. Well, the square root of x plus 2 plus 1 squared means we're doing the square root of x plus 2 plus 1 times the square root of x plus 2 plus 1. And on the other side, it becomes 3 minus x. Now I'm going to FOIL on the left-hand side. Square root of x plus 2 times the square root of x plus 2 is x plus 2. Square root of x plus 2 times 1 is the square root of x plus 2. Square root of 1 times the square root of x plus 2 is square root of x plus 2. And then 1 times 1 is 1. I am going to combine those square roots. So I have 2 square roots of x plus 2. And then I have plus x. And then I have 2 plus 1, which is a plus 3. And that's equal to 3 minus x. Now at this point, I'm going to go ahead and move the x over by subtracting it and the 3. So I get 2 times the square root of x plus 2 equals negative 2x. So notice I'm trying to get the square root alone. That's what I'm doing now, because I want to get rid of that second square root. Then I'm going to divide by 2. So I get the square root of x plus 2 equals negative x. Now, since that square root's alone, I can square both sides to get x plus 2 equals x squared. And then from here, I can get everything to one side to create a trinomial. So I'm going to go ahead and subtract x, subtract 2. So I get 0 is equal to x squared minus x minus 2. I'm going to go ahead and factor this. If the problem wasn't factorable, you could use the quadratic formula to figure it out instead. For this one, I can use x minus 2 times x plus 1. So I end up getting x minus 2 equals 0, x plus 1 equals 0. So I get x equal to 2 and x equal to negative 1. So we get these two answers. Now it's important that you always check to make sure there's no extraneous solutions. So let's go ahead and check these in the original problem one at a time. So I'm going to check x equals 2 first, which means I'm going to have the square root of 2 plus 2 plus 1, and I'm going to see if that's equal to the square root of 3 minus 2. Well, the square root of 2 plus 2 becomes the square root of 4 plus 1 equals the square root of 1. The square root of 4 is 2, so I have 2 plus 1 equals 1. I end up getting 3 equals 1, which is not true, so that means 2 is an extraneous solution. You'll cross that out. Now let's check negative 1. When we plug in negative 1, I get the square root of negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. So I get the square root of 1 plus 1 equals, this becomes a plus, so we get the square root of 4. Square root of 1 is 1, so I have 1 plus 1 equals, square root of 4 is 2, so I get 2 equals 2, which means that negative 1 is in fact a solution. And that's it for that problem, as well as these notes. If you have any questions, be sure to contact your teacher.